And the doc I linked to here is just the quick start. If you take the quick start code and run it, it is going to give you a POS tag for all of the tokens that are inputs. So for example, if I have a sentence that I'm feeding to the model, that sentence is going to be tokenized, and then I can print out the text and the POS for the tokens. But in addition to POS, there's also a tag. So POS, part of speech, that is going to be a tag that was generalized from the actual base tag. So we're interested in the base tag here. So when we look at my code in a minute, we'll change, we might want to change POS to the base tag. This uses the Core Web SM for small model. If you want to increase the accuracy, you might want to use the TRF model. This is a model based on a transformer that has been shown to have very high accuracy, but it's going to be less efficient to use. So for our purposes, we can use the smaller efficiency model. When you want to run scripts in spaCy, you're going to want to first download your model. So this first line of code here is going to download the model that you want to use, and then the rest of this is the script that you will run. While we're here in the docs, an interesting thing to look at, even if you're not using spaCy, these docs give you a lot of information about natural language processing in general. If we go to the processing pipelines, you're going to see NLP processing steps. And so this is showing you how spaCy is going through these processing steps and which components it's using. So your input text first goes through a tokenizer, so that's the tokenizer component, and it creates a document that has segmented the text into tokens. And then it goes through a tagger, and it creates token.tag, where it's assigning a part of speech tag, and so on. So you can see it going through the pipeline. So these are the steps that we saw earlier in this course, the 7 steps of processing for NLP. So we go through the tokenizer, the tagger, we do dependency parsing, named entity recognition, lemmatizing, text categorization. So this is assigning document labels. And then there's some other custom things that you can have as well. So every time we run this model, we are running it through this pipeline, which is giving us a lot of output data. So if we go back to the quick start example here, we're only outputting the POS, which would be the part of speech label that was assigned. That's the only output that's given here. If we go back to the code, you can see I've replaced POS with tag here. So let's look at this code a little bit closer. So first I'm going to import spaCy, then I'm going to import NLTK and the POS tag function. I'm going to use the same quotes that I used up above. And remember, I needed to download the model first, so I put this here as a comment to remind you, download the model before this load command will work. So I'm loading the spaCy model and storing it in NLP. And now I'm going to go through, for quote unquote, so I'm going to go through each of these sentences. And I'm first going to print the quote. And then I'm going to tokenize it for NLTK. So NLTK POS tag expects a list of tokens, and what I have is a sentence. So I'm first going to call the word tokenize command and create the tokens. And then for NLTK, I'm going to use the POS tag function from NLTK, send it the list of tokens, and then I'll get my NLTK tags for each of these quotes. For spaCy, syntax is a little bit different. So for spaCy tags, I have already loaded my model and stored it in the NLP variable. So for each quote, I'm going to send NLP the quote. Remember, we saw that the pipeline is already going to tokenize for us. So I can just send the model directly the quote. It's going to be tokenized, tagged, among other things. And I'm going to iterate over the output of that, and for each token in spaCy tags, I'm going to store the text of the token and then the actual tag. So when we looked at the getting started example, they had POS here instead of tag. So POS is part of speech, and that is going to be a more generalized tag where we want to compare spaCy directly to NLTK. So we want to use the full, more specific tag set. So instead of POS, I'm going to put tag here. And then I'm going to zip these two things together. So now I have my NLTK tags, which is in the form of a list of tuples, where the first one is the token and the second is the tag. I did the same thing with my spaCy tags. I created a list of tuples where the first is the token and the second is the tag. So I can zip these two lists of tuples together. They should be the same length. And just to check to be sure, I'm going to validate as I iterate through these zipped tuples that they are actually aligning, meaning that each one is going to show me the tag for the same token. That's what that does there. And then I'm going to append the actual token itself, followed by the NLTK tag, followed by the spaCy tag, and then I'm going to use Python's tabulate library to print this out nicely on the command line. And this is what the output looks like. So if you copy this code, run it, you should see this output. So it first outputs the quote, and then it gives you a little table of the token, the NLTK tag, and the spaCy tag. And you can see for the most part, these are lining up. So these are comparable tools that we use. And let's see if we can find one that's different. Yeah, it looks like oh, here we go. Here's one that's a little different. All right, so the word to, NLTK returns the class to, spaCy returns the class in. Go back up to the table and see what those classes are. So NLTK, there's this class that only has to in it, probably because in the English language there's too many twos. So it has its own category here. And IN, preposition or subordinating conjunction, is what spaCy labeled that word. So that is one where I would take that and say, okay, well, let's try this in other taggers and see what other taggers do, and then maybe do some research on the language and see which one of these should be considered accurate